In this video, we're going to talk about for loops. For loops are a special type of control structure in most programming languages. And if you remember, a control structure is something that changes the default flow through a program. The first type of control structure that we took a look at were if statements. Those were a type of conditional statement that determined whether or not we were going to execute some block of code. So a for loop is this class of looping control structures that determine how many times we're going to execute a block of code. So we're going to take a look at what those look like and how they work. But before that, I want to kind of revisit or talk a little bit more about these special assignment operators. These aren't anything necessarily new. These are just kind of a shorthand way of writing stuff that is commonly used within for loops, because for loops we need to try and make kind of succinct because there are three kind of chunks or statements that go along with it. So it's pretty common to use these shorthand notations that combine an arithmetic operator with an assignment operator. So again, it's not necessary, but it helps make the code a little bit smaller and more concise. And so on the left-hand side, it shows this shorthand equivalent where we're combining the arithmetic operator with an assignment operator. And then on the right-hand side, it shows like the equivalent assignment. So if I just need to add some value y to the previous value of x and update x's value, I could just write x plus equals y, which is the equivalent of saying x equals x plus y. And all of those same style of operators exist for each one of my arithmetic operators. So addition, subtraction, multiplication, division, and modulo. And then if I just need to update a value by 1, say take the previous value of x and add 1 to it to increment that value by 1, there's an even shorter shorthand that is x plus plus. And then if I just need to subtract 1 from x, what I do is I say x minus minus. And so these x plus plus and x minus minus are kind of the most common things you would see in a for loop. So let's take a look at what a for loop looks like here. So the first thing you might notice is in looking at this isn't like full completed code. These are just kind of abbreviations of what's happening here. But you notice that it kind of resembles a little bit of an if statement. For an if statement, we had the word if, we had the same parentheses here, and then we had some curly brackets. And in between those curly brackets, we had code that we would execute if that condition within the if statement was true. So for a for loop, we have the parentheses, but then inside of the parentheses, we have three different statements here, one of which is still the condition that we check. And if that condition is true, what's going to happen is we're still going to perform the code that is inside of these curly braces here that we would call the loop body. It's just, it can be one line of code or many lines of code that we're going to execute while this condition is true. So that's the important distinction, is it's not just once, which is like whether or not, like for our if statement, we would perform that. We're going to perform it some expected number of times based on what we put inside of here, and perform it a number of times over and over and over again. So we have these three distinct statements here. We have the initialization, the condition, and the update. So the way that a for loop works is what it will do is before it even performs what's inside of the loop body, it will perform this initialization step. That is performed once at the very beginning before we check the condition. And so typically what happens is we declare and initialize a control variable. This is a variable that is controlling how many times we're going to execute this loop. And so we do that first. So we would maybe declare some variable, set it equal to some value. And then immediately after that, we check the condition. So we say, okay, this condition is some true false Boolean expression that checks that control variable and says, okay, is this control variable maybe less than some other value? If that's true, what happens is it goes down into the loop body and it performs the lines of code inside of there. Once our loop body is done, what happens is it comes back up and it goes to the update statement here. And so what the update statement does is it runs every time after the loop body, and it typically updates that control variable. Oftentimes it just increments or decrements that control variable. And then once the update block is done, it then goes to the condition and checks that condition again. If that condition is still true, it will then go inside of the loop body, and then after the loop body go to update and update that variable, and then the condition will check that variable again. And if that variable continues to be true, it'll do the loop body again and again and again until the update changes that variable so that this condition is no longer true. Then our loop is done and it goes on to the rest of the program. So this is a look at the flow chart for this that pretty much summarizes what I just said. So the first step is we come in, we perform the initialization statement here, and then we check the condition. So if the condition is false, we just skip over all of this and go on to the rest of the program. If that condition is true, we perform the lines of code associated with the loop body inside of here. Once we're done with the loop body, what we do is we then go up to the update and we update that control variable, and then we test our condition again. And so if that condition is true, we keep repeating these steps over and over again. And then once the condition is no longer true, we stop our loop and we go on to the rest of the program. So I think this might make a little bit more sense if we pivot to looking at a couple of examples here. So here on this slide, there are 4 different examples here. So we'll just kind of break them down one by one. So here is our first for loop. And so all that this is doing is just printing out some variable I every time the loop executes. So we can see here in our initialization step, what happens is it declares some integer variable I and it sets it equal to 0. Then our condition here checks to see, okay, is I less than 100? If it is, it will then go inside of our loop and perform the steps inside there, which is just the single line of code that prints the value. Once the loop body is done, it goes up to the update here, where it says I++, basically incrementing our value of I by 1 so that it goes from 0 to 1. Then it would go to our condition here and say, okay, well, is 1 less than 100? So yes, that's true. So then it would print the next value, which would be 1. And then it goes up and adds 1 to that, so it becomes 2. Is 2 less than 100? Yes, it is. So then we come down here and we print 2. Then we add 1 to 2 and it's 3. Check if 3 is less than 100. Go inside the loop body and over and over and over again until we get to a value of 99. So 99 is less than 100. We would print that value of 99, and then we would come up here and add 1 to 99 so that it is now 100. And then it asks the question of this condition where it says, okay, is I, which is 100, less than 100? And the answer to that is no, it's no longer less than 100, it is equal to that value. So what happens is our loop would stop running. So this loop right here, what it does is it would print all numbers, all integer values from 0 to 99, because I goes from 0 up to, but not including 100 in steps of 1. So this is our initialization, our starting value of our control variable. This is our ending value of the control variable where it would go up to 100, but it does not include 100 because we're saying for all values less than 100. And this is saying, okay, step through those values one at a time by adding 1 each time. Okay? So here, this is a slightly modified version of this, where what we're going to do is we're going to initialize our value of I to be 1, and then we're going to keep our loop going while I is less than 101. But instead of adding 1 each time, what we do is we're adding 2. That's what I plus equals 2 means. It's I equals the previous value of I plus 2. And so what this loop would essentially do is print all of our odd numbers from 1 to 100, basically. So 100's not an odd number, so maybe I kind of wrote that a little weird, right? But it would go from 1 to 99. And the reason for that is we start at 1. 1 is less than 101, so then it prints 1. And then we come up here and we add 2 to 1, so it's 3. 3 is less than 101, so it prints 3, and it keeps going and going and going. Once we get to 99, it prints 99, it adds 2 to 99, and then we have 101, which is no longer less than 101, so it would stop the loop, and the last value this would print would be 99. Now here, this does something kind of similar, but because our initialization here starts at I equals 2, it's going to print even numbers because we're going still in steps of 2 from I equals 2 all the way up to 101. So it prints all the even numbers from 1 to 100, basically, starting at 2, 2, 4, 6, 8, all the way up to 100 here. And this last one, you can kind of like catch on to what's happening here, right? So this one starts at 3, still goes up 2, but does not include the value of 101, and adds 3 each time to the value of I. So first it would print 3, and then it would print 6, and then it would print 9 and 12, all the way up to 99, and then it would stop. So that's how these for loops work. If you wanted to try these out, you could copy and paste this into your Arduino environment and just try to print out the values and make sure it makes sense. But that's kind of some basic examples here with for loops. These are pretty similar to what we just did, right? So this is some value of I started at 0, and then it goes up to but does not include 10, and then we add 1 to I each time. So the result would just be it printing values, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we could go from a higher value to a lower value by saying, okay, let's start I at 20. Let's continue to subtract 2 from I while I is greater than 0. So it would say, okay, is 20 greater than 0? Yes, let's print 20. And then we'd subtract 2 from that, so it would be 18. Is 18 greater than 0? Yes. So we keep going and going and going until we print our last value of 2. Then we subtract 2 from 2, so it becomes 0. And 0 is no longer greater than 0, so it would stop. So these are all pretty contrived examples, right? They're just printing out values. It's not really anything that we would typically do in a full-fledged Arduino program, but maybe this is something more in line with what we would do. So here what we're doing is we're again creating some variable I that starts at 0. We're repeating this loop while I is less than 20, and every time the loop executes, we're adding 1 to I. Inside of the loop body, what you can see is we are going to take the value of I, which for the first time is 0. So if we do 0 mod 2, remember mod or the percent sign gives us the remainder. So if we say 0 mod 2 equals 0, that would be true for all even values of I, right? So this is basically just checking if I is even. If I is even, what happens is it turns on the LED. Then we have this else statement here that is paired with this if that says, okay, well, if I mod 2 does not equal 0, meaning that basically I is a odd number, it would then turn off the LED. So what happens is every time the body of this loop executes, we're either turning on the LED or off the LED, and then we're waiting 500 milliseconds. So eventually what this loop would do, if we kind of follow it all the way through, is it would, the first time the loop executes, it turns on the LED because my value of I is 0, and then it waits 500 milliseconds. Then I becomes 1, which is less than 20, and I mod 2 when I is 1, so 1 mod 2 does not equal 0, so it would come down here and it would turn off my LED and then wait 500 milliseconds. So it's just toggling whether it's turning on or off the LED pin based on whether I is an even or odd number. So since this loop repeats 20 times, because we're going from 0 all the way up to but not including 20, what happens is it basically turns on and off the LED 10 different times, where every other time it's turning it on and every other time it's turning it off. So this might be kind of something more in line with what we would actually do, and it showcases a few different things. It showcases the fact that we can combine, if statements inside of our for loops or for loops inside of our if statements. This is something kind of more in line with what we would do. All right, so I want to talk about a common error that you might run into as you're writing your very first loops, and that is something known as an infinite loop, where a loop never ends because we wrote it incorrectly. So it's typically caused by one of two factors. It's typically that the condition that we are checking is never updated, or the condition that is checked is incorrect. So here in this first one, I'm starting I at 0, and then I'm saying let's continue this loop while I is less than 10. But then I'm saying every time after the loop body executes, we're going to update the value of I by subtracting 1 from it. So I would become 0, and then -1, and then -2, and then -3, which would mean that I is always less than 10 because it just gets more and more negative. So this loop would never end. So maybe what we meant to do was say add 1 to I here so that it didn't just continue to run forever. That's one example of an infinite loop. Here's another one where what I'm doing is I'm creating some variable before the loop called sum, and then I'm creating a variable called I inside of the loop. Here is my initialization step, setting it equal to 0, and then my condition here is just saying is 0 less than 10. So maybe I accidentally meant to put I here as opposed to 0 because no part of this condition is changing. 0 is always going to be less than 10, so this loop would continue to run over and over again. So I probably meant to put I here, and then I would eventually stop because this loop would eventually stop because we are adding 1 to I. So I would continue to increase, and then once it got to 10, this loop would stop. And essentially what it's doing is it's just adding I to sum each time to compute the sum of all the values from 0 all the way up to 9. So this just kind of shows a couple of ways that a loop might misbehave, and it would be stuck here forever and never get to the rest of your program. So if something is not quite working correctly in your Arduino and it doesn't seem like it's getting to another part of your code, maybe check your loop conditions to make sure that you don't have some sort of infinite loop here. And it can be helpful to put print statements throughout to check to see what's going on. And I guess kind of in closing, I mentioned this just before, but just like if statements, right, you can put loops inside of loops or if statements inside of other if statements inside of if statements, loops inside of loops, and vice versa. You could put ifs inside of loops, loops inside of ifs, and so on, right? So you could try out these chunks of code here and see how it performs. This is something that we probably wouldn't get too far in, like nesting loops inside of loops, but it could be helpful in certain scenarios that we might talk about later on with like LED matrices and things like that. But yeah, I invite you to try that out on your own.